In this video, I'm going to go through an example of finding the equation of a tangent. Now, this is a key concept which appears in pretty much every IB Maths exam you'll face. Okay, so the question says find the equation of the tangent to our function here fx when x is equal to 2. So on our x-axis here, when x is equal to 2, if we go up, we can go to where our y value is, and we can find the y value just by subbing in 2 into our original equation. So f of 2 will be 2 squared, which is 4. So this is 4 here, and we know this point has the coordinates 2, 4. Now what a tangent line is a straight line which just comes and shaves that point on the curved line. And this will be a straight line that has a linear equation. And back when we did coordinate geometry, we learned how to find the equation of a straight line, and it will be in the form of y equals mx plus c. So that's what we need to do. We need to find the equation of this tangent at this exact point. Now the steps to find the equation of a tangent are, we first need to take our function and find the derivative. So f dash of x, our first derivative, will be 2x. Now what the first derivative actually means on a curved line, it means we've actually just found the gradient equation. And what I mean by a gradient equation is that if we then sub in an x value into the derivative, we then find the gradient at that x value. So the first derivative helps us find gradients on curved lines, the slopes on curved lines. And we want to find the slope at this exact point here, because that will be the slope of our tangent. And that exact point has the x value of 2. So if I sub in 2 into my derivative, I'll get 2 times 2, which is 4. And what that means is the gradient, which is m, of the tangent when x equals 2 was 4. And now that we have the gradient at this dot here, this red dot, and we also know the x and the y value at that dot, we can use the equation of a straight line to find the equation of our tangent. So we just use y equals mx plus c. We know to find the value of c, which was our y-intercept, we can sub in our gradient, which is 4. I'm also going to sub in the known x and y point that we have, 2 and 4. So 4 was the y, x was 2, then plus c. So 4 is equal to 8 plus c, and if I move the 8 over as a negative, c will be equal to negative 4. And once I have c, I now have my equation of my tangent, because y equals m, which was 4x minus c, which is minus 4. Okay, so that's the process of finding the equation of a tangent. What we need is an x and a y point. To find the y point, if it's not given in the question, we sub the x point into our original function to find the y point. And once we have that, all we need is the slope at that point, and that's why we use the first derivative and sub in the x point here. Okay, so I encourage you to practice a bunch of these questions. They may ask you to find, after the tangent, the normal, and what the normal to the curve is the straight line which is perpendicular to the tangent. And all you need to do there is exactly the same process as what we just did then. We need an x and a y point, which will actually be the same for a tangent and normal, but we just need the slope of the normal, which is the negative reciprocal of the slope of the tangent. So in this case here, our m would be negative 1 on 4. And then we would just use the equation of a straight line. Okay, I encourage you to practice a bunch of these questions, so good luck.